The American felling axe evolved from its European counterpart, which was best suited for chopping down smaller trees. As settlers encountered the hardwood forests of North America in the late 18th century, axe designs became larger, heavier, and more specialized for efficient tree felling. This eventually led to the true American felling axe, characterized by a wider bit, a thinner profile for deeper cutting, and a longer handle to generate a more powerful swing. We made several mock-up designs based on the profile of an American felling axe, keeping the wide cutting edge and a thin profile in our final design. With the design complete, we used a bandsaw to cut a 5" by 2" by 2" billet of 1045 steel, then milled out a reference point for the eye. 1045 has a similar balance of hardness and toughness to what early blacksmiths used, with the added bonus that its properties could be more finely tuned via heat treatment. Up next is forging. After last year's competition, we made some updates to our setup, including a back wall and a roof to keep the fire more insulated, and an air duct system to warm the air from the blower before sending it into the forge. With our improved forge setup lit with charcoal, it was time to throw our coke onto the fire and,
Yeah, don't breathe that.
So, turns out we had accidentally bulk ordered coal, not coke. It runs out faster, burns dirtier, and contains a lot more moisture than our usual choice. But with the time and budgeting constraints we were under, it would have to do for this project. Once the smoke had mostly cleared, we began by punching a hole through the billet. This process required multiple strikers to progress quickly, so it took some time and planning to coordinate our movements. After a few forging rotations, we'd gotten into a good rhythm. We'd also figured out how to make the most of the coal, as we were able to shape a small cave that the workpiece could fit into. This would trap hot air around the metal and keep it warmer than our previous open-air forging setup. Next, we used a drift to expand and shape the eye. The goal was to leave an hourglass shape in the center of the axe head to better secure it to the handle later on.
Wow.
Since our normal drift wasn't large enough for this project, we made another one from an old tire iron. After the eye was complete, we could start drawing out the material with a flatter to create the overall length and rough profile of the axe. But with bad weather on the way, we needed to wrap up quickly before our axe head got forcibly water quenched. Over the next few forging days, we created the curved transition between the blade and the body of the axe using the anvil's horn, alternating sides during forging to ensure angle symmetry and to avoid excessive thinning on one side. This also ensured that the edge profile remained centered relative to the eye. We moved on to grinding via a belt grinder to smooth out the axe head and make the profile more visible. For our heat treatment, we used a normalizing cycle to give the axe a refined microstructure, which would keep the effects of future heat treatments consistent throughout the bulk. We chose a differential hardening procedure for our quench. The cutting edge was quenched quickly in water to achieve a hard, martensitic structure, while the bulk cooled in air to maintain a softer, more ductile core. We heated one last time to create a tempered martensite structure on the edge, reducing the risk of brittle fracture. This was followed by a lot of filing and sanding to finish the surface and leave a sharp edge. And to avoid the same mistakes as last year, we milled around the eye to create a wider hourglass shape. This would make it harder for the head to fly off once the handle has been split by the wedge. We chose hickory for our handle because of its high toughness, strength, and shock absorption. We modified our pre-built handle to fit our eye dimensions using a Shinto rasp. Then we had to cut off the access, saw a deeper notch for the axe head, and drive in a wedge. We made sure to fill in the gaps completely with extra wood pieces. Then we were in the home stretch. Wood burning for aesthetic purposes. Might have overdone that part of it. Linseed oil to seal in moisture. And of course, we had to test it.